Our closing session is on standards and information technology. And we're happy to welcome Dorothy Stanley from the Hewlett-Packard Enterprise Institute of Electrical and Electronics Engineers. She's very active with ITripleE. And we're going to follow on with Daniel Ryan, who's the Director of Standards Programs at the Underwriters Laboratories. So let's please welcome Dorothy Stanley.
Okay. I have the mic. Thank you very much, and it's my pleasure to be here and to speak with you on the topic of the ITripleE standards development process, and in particular the ITripleE 802.11 standard and the impact it has on society and some applications of products, 802.11 based products, for public safety applications. So my talk is structured in three parts, as you see here. First, we'll talk about ITripleE and its standards development process. Much as ASTM International has its standards development process, so does ITripleE. So we'll talk about that topic broadly. Then we'll focus in on ITripleE 802.11, which is the technical standard that Wi-Fi products are based on. And that's the area where I've been working for approximately the past 20 years. In the introduction, the company that I work for is HP Enterprise, or Hewlett-Packard Enterprise, specifically the Aruba Networks division. Aruba Networks is the division that builds the wireless LAN-based products. So we'll talk about that. And then we'll talk briefly about some of the drivers for standards development and the impact, the new work that we're doing, and then some examples of how our products are used for public safety. Okay, ignore you. Okay. So first, ITripleE and ITripleE standards development. ITripleE broadly has many components. You can see the aspects highlighted here. So ITripleE is a technical organization that supports that you can be a member of ITripleE. Probably many of you here perhaps are members of a student chapter or professionally a member of ITripleE. So there are approximately over 400,000 members of ITripleE. There are 46 technical societies and councils within ITripleE. Everything ranging from Power and Energy Society, Computer Society, Communication Society, Biomedical and Engineering Society, just an incredibly broad spectrum of technical areas where people can be active, publish in journals, have local meetings, etc. Then what do we have? 160 countries. So all of these members are active globally. So it's a very broad, globally reaching institute. That's ITripleE just at the very highest level. You can read these other aspects too in terms of conferences. There we go. Technical documents, top-cited periodicals, and active standards. So currently there are 1,300 or more active standards. And of course Wi-Fi or 802.11 is the one that's highlighted here. Okay. All right. So that's ITripleE broadly. So there are many, many aspects that are non-standards related within ITripleE. We're going to focus on the standards related piece. So the ITripleE Standards Association defines a standards development methodology and forum where standards can be developed. The standards are managed effectively by the societies and the standards committees within those societies. So you can have standards that are sponsored by the Computer Society, sponsored by the Communication Society, sponsored by one of the committees within Power and Energy Society. So it's really a very grassroots effort where a proposed standard can come into existence and be proposed. And you see some of these topics here. Aerospace, power and electronics reliability, radiation and nuclear, transportation technology. There's also a set of standards that was developed more recently on ethics, and ethics in design, ethics in engineering. So really an area where a lot of attention has not been paid in terms of standards. So it's a new area, and there's been really a global participation in the development of those standards. And ITripleE has been recognized globally and, for example, at the European Commission level as taking the lead in developing that type of standard. Okay. This is a resource for you. Online, ITripleE Standards University has a lot of information about standards development in general, the ITripleE standards development process in particular, and a lot of resources you can use to learn more about the standards development process. So I encourage especially the students here, this is a great resource for you. Okay. So now let's talk about the ITripleE Standards Association, or ITripleE SA, and the processes that it defines. The presentation that we had, the very first presentation today, talked about a standards development process. This is, on the left you can see individual membership, corporate membership. So I believe for ASTM International, the process was one company or one entity, one vote. That's really the corporate model. So you have a corporation, regardless of size, it gets one vote. You can set up a standards development organization or structure and process that way. ITripleE has two models that are supported. One is the one corporation, one entity, one vote. That's the corporate model. The other is the individual process, where it's one person, one vote. Okay, so it really depends on the people there. So you can come, you can participate. You don't have to be a corporate member or a participant, have a corporate membership to do that. You just come and you attend. So the 802 and 802.11 standards are all developed under the individual membership model. So anyone, anywhere across the globe can come to our meetings, can attend teleconferences, and participate in the development of the standard. I'll talk a little bit about a couple of touch points where you can actually get copies of the standards as they're being developed, submit comments, review the documents, etc. Currently, there are on the order of 20,000 active standards developers across all of the projects. The rainbow circle on your right shows the steps that are followed in developing a standard. So first, a new project is proposed. This is called initiating the project. And a project is proposed, again, within a society and within a standards committee. Then once that project is defined, its scope defined. So what's the scope? The scope is like the outer bound of the sandbox in which the work can be done. You can develop the standard that does less than is defined in the scope, but not more, right? So it's setting a boundary so that other people globally know really what you're going to be doing, and this helps to minimize overlap of projects. Then a working group is formed, the standard is drafted, and then the standard is balloted. So within the drafting phase, there is another balloting, a sub-process, if you will. So within once a working group is identified, a draft of the standard is developed and is balloted within the working group. So the working group is the set of people who come together to develop that standard. Once the standard has matured and the working group approves it, now the draft goes to ITripleE Standards Association balloting. This is one of the touch points where literally anyone on the globe can sign up to be an ITripleE SA member, Standards Association member, for a relatively nominal fee. And you can be a member of the ballot pool, or the set of people who submit comments on that document. You will get a copy of the draft standard, and you can submit comments. So that's one of the 2 touch points where you can get involved, and you can get a copy of actually any ITripleE standard that's being developed. The second point is just before gaining final approval from the ITripleE Standards Board, there's a public review process. So all of the standards as part of the ITripleE SA balloting go out for a public review and comment. So I believe it's a 60-day period where you can go to the ITripleE website, you can see all the standards that are going to come up and go through this public review process. You can participate in that public review. So for example, when I talk about one of our standards that will be coming very soon, 802.11ax, right, or the Wi-Fi 6 standard, there will be a public review period for that. And you or anyone else can sign up and get a copy of the standard and read it to your heart's content and submit comments. Okay, so that's ITripleE. ITripleE standards development, corporate model, individual model, the general development process. Now let's take a look at ITripleE 802.11 and ITripleE 802. So underneath the Computer Society, there's a standards committee, and one of the standards committees that is 802. It's the Landman Standards Committee. And we focus on the MAC and PHY layers. So this is a communication system, and that's where we focus. MAC and PHY. The upper layers we take from IETF. IETF, Internet Engineering Task Force. These are the folks that define IP, Internet Protocol, TCP, HTTP, all of the Internet protocols that really make the Internet run and work. Right? So we're able to leverage all those upper layers. We don't have to redefine them. We define specific MAC and PHYs. So .11, you can see 802.1, 802.3. I'll talk briefly about those, and then we'll focus on 802.11. 802.15, these folks developed some UWB standards, and then you can see some of the others here. If we had more time, I'd go through each of those, but we don't. Okay, so very briefly, 802.1 and 802.3 and their relevance. So 802.1 is really the architecture group for all of the 802 standards. So they define bridging protocols, QoS protocols, etc. One of their work areas that is of particular interest is time-sensitive networking. So there's an initiative globally called Industry 4.0, which is how does manufacturing and industrial automation, all these processes, how do they evolve to take advantage of computing and computing technology? And you have a lot of processes, manufacturing processes, that really need additional functionality that's not there in most networks today. Talking about the time-critical or mission-critical applications. So you have very low latency, low jitter, high reliability requirements on your communication system. That communication system might be within, for example, part of a manufacturing line, right? But you want to be able to increase the communication among the components of that line and have certain characteristics. So they have defined a number of protocols that actually provide those characteristics. Today, those characteristics, and there are a couple of links here that will give you more information. Today, those TSN protocols are defined to run over Ethernet. Ethernet is defined by 802.3, the 802.3 working group. It's chaired by David Law. David is based in Scotland. He's also an HPE employee, so we chat often. What I've provided here is a list of the current active projects within 802.3. So you might say, well, Dorothy, Ethernet has been around for a long, long time, right? Isn't it just this cable I have in the wall? Does it really have to be so complicated? Well, you'd be amazed. There are so many applications that are coming that use Ethernet, and different flavors and variety of Ethernet, whether it's over cable, over optical, over very short range. One of the most recent applications has been automotive. Okay, and you say, well, why automotive? Why automotive? Because today the wiring harness in a car is one of the heaviest components in a car. Why do you want to reduce weight in a car? Improve fuel efficiency, right? So there are many ways and many really attack vectors against how to make cars more efficient. This is one of them, reducing weight. So all of the communication buses and interfaces that are currently in a car are being redesigned to use Ethernet. Each of those may have different requirements in terms of latency, range, and length of the cable, and throughput. So there are a lot of these that are specialized for that application. Okay, so these are our peers within 802. So now let's focus on 802.11. This picture tries to show we have 802.11, which is the working group. Why am I talking about 802.11? I'm honored to serve as 802.11 chair. So I've been active within 802.11 for about 20 years, as I mentioned. And so I've kind of come up through the ranks doing different tasks within that group. So the way we operate is we really are aiming for commercial relevance, right? We do developments, we develop amendments, we make changes to our standard to continue to be market-driven and commercially relevant. So, what is needed in the market? How can we continually improve our technology? So we have a structure. We take inputs. We're not an island. We take inputs from regulatory, from academia, from industry, from research, and all of those feed into improvements and developments that we might undertake in the standard. Here's a list of the currently active groups. On the far your left, you'll see what I've entitled Working Group and Infrastructure. So, just like any organization, there are certain functions you have to kind of keep the lights on, right? And that's what those are. We don't really have the time to go through all of those. I might mention the last one, ISO, IEC, JTC1, SC6. ITripleE is a global organization. We develop standards that are used internationally. There was mentioned before about WTO and TBTT, and ISO, IEC, these are United Nations designated international standards bodies. So if you want a official UN designated international standards stamp, you have to get that from one of 3 or 4 specific bodies. ISO, IEC, JTC1, SC6 is the body that we take our standards to, and they review it, and typically the documents are then issued as ISO standards. So this is how we get that official stamp. We're enabling our standards to be used without barrier globally. Right, and that's important for enabling the market to operate effectively. Then the next area is where new work is identified. 5 minutes, oh my gosh. I want to mention one topic interest group that we currently have ongoing, which is random and changing MAC addresses. This is a topic interest group. It may or may not lead to changes in the standard, but it has to do with privacy. A MAC address, you probably all know what a MAC address is, right? Every device has many of them. And so there are people who can, over a wireless system, use that MAC address to track people. Right? So a lot of vendors now, all of the handsets, et cetera, all of the vendors have implemented randomization of MAC addresses so that you can no longer track someone just with the MAC address. However, there are other characteristics that can be used. So we've developed standards, there are published standards on how to develop your system so that those items cannot be used to track you, right? And so now we're looking at, given that these MAC addresses are changing so quickly, what is the impact upward into the network stack and into the different systems? But that whole area of privacy and the need for privacy is one that really has impacted our work. So that's coming to us. On the right, yes. So these are the active amendments that we have going. High efficiency wireless LAN, 802.11ax. This will become, this is being marketed now as Wi-Fi 6. There are products in the market, even though the standard isn't finished. The foundational pieces are there so that products can be built. We have development for next generation 60 gigahertz. So the fundamental wireless LAN standard like 11ax is in 2.4 and 5 gigahertz. What's important about 2.4 especially? When Wi-Fi really came and became a market success, it was because of the global availability of the 2.4 band. Okay? The global availability of the 2.4 band did not happen by magic. There is no magic, you know, it's all hard work. It happened because a lot of work was done to harmonize the RF spectrum usage at 2.4. There are slight differences in Japan, you have some higher bands, et cetera, but by and large, most of the globe, you support 2.4. And that's what enabled the whole ecosystem really to be developed. And this is the interface to regulatory, right? The FCC, right? The FCC took a leap of faith in making the ISM band in 2.4 unlicensed and available for general use, right? And so what this Wi-Fi ecosystem and 802.11 standard has done is really taken spectrum that was viewed as not very valuable and turned it into, you know, trillions of dollars of economic value. There was a study that was done by the Wi-Fi Alliance that showed the economic benefit of Wi-Fi, and it's literally in the trillions of dollars. So if you think about the impact of standards, right? What an amazing success example, right? Just to bring that kind of value to the world. Okay, I've gotten the 5-minute sign, so we're going to go very quickly. You can review this later. I'll highlight one thing here, and then I think we'll have to stop. What are the characteristics that drive innovation for us? And it's really these 4 things. One is the demand for throughput. You know yourself, right? The applications that you have on your devices now are so far from the ones of even 10 years ago, right? The things you can do, the movies you can download, et cetera. And so as a user, you have a need for much higher throughput. And this is continually driving our innovation and our standards development. And then new usage models, I want to highlight automotive, dense deployments, indoor location. There's a lot of work going on to, you know, you have your access points up here connecting as, of course, via power over Ethernet cables. But to use that infrastructure for indoor location applications. And so we have a mechanism now, it's called fine timing measurement. The work underway in 11AZ will make the precision on those timing mechanisms much, much finer. Then technical capabilities and changes to regulation. So this is what's driving our system. So the rest of this you're going to have to go over on your own time. I'd like to highlight just a couple of items, not on the technical side, right? But really, the standards development process comes down to people sitting down together and talking, right? Identifying problems, making proposals, working out differences, and coming to consensus about a body of work that they will bring forward. And what I've observed is, you know, to go into that process, and I hope some of you do have the opportunity to become involved in standards development over the course of your career. You know, as you can attest, I mean, I started in Bell Labs too, way back when, and you know, in network systems product development, or you know, systems development, and it's one thing to work inside a company and build a product. It's another thing to work with your effectively peers across other companies and organizations. And you know, you have to not take things personally, right? You have to have a bit of a thick skin, because you know, it's not about you. You may have developed your proposal and you thought it was perfect. You crafted it and you put it on a pedestal and it is magnificent. Well, not everybody thinks so. But you know, the goal is that when the product comes out, it will be something that the whole world can use. So you don't want everybody to just agree with you and say it's beautiful and wonderful, right? You want to find the flaws, okay? You better find them early. Better to find them early than to find them late. So I have seen this over and over again, right? Somebody comes with that, but anyway, so I would again urge you, and maybe this is just a general life lesson, is you have to A, not take it personally. B, you want to find issues early, and just you have to listen to other points of view. You know, and you do learn a lot. And the other thing is that we see over and over again is the more you can be data driven, the better it is. You know, you ask the question about, you know, why are there so many standards internationally? You know, internationally you have national this, national that, national that. Well, you know, not invented here is real. It just is. It's real. And to overcome that and say, okay, well, I'm going to give up this because I know the data shows X. You know, be honest with your simulations, right? You have to be ethical and honest about this, because at the end of the day, the product will go out. You want it to be successful. You want it to be good. And it's sometimes a painful process to go through, but really, when you come out with a standard that then is adopted in the marketplace, it's really exceptionally satisfying. So thank you for the opportunity here. Okay.
Now I'd like to welcome our last speaker for the day, and that'll be Daniel Ryan, who's the Director of Standards Programs for the Underwriter Laboratories.
Well, thank you. So, end of the day, last presentation before dinner. If I could have a couple people seal the exits, and if somebody could call the facilities people and let them know to release the hounds into the atrium, we shouldn't have any more interruptions. Before I even get started, though, I was just springboarding off Dorothy's comment about it not invented here. There's a great quotation I heard from somebody at Standards Australia a couple years ago, and they said, standards are a lot like toothbrushes. You know, everybody agrees it's a good idea to have one, but nobody wants to use anybody else's, right? So I think that's true. So really, first, a big thank you to the staff and faculty here for the invitation to participate in this event. I think it's just amazing to me how much you're incorporating standards into your curricula. The students who are going through this program will be so much farther ahead than I was when I graduated with a bachelor's degree in mechanical engineering back in 1983 and went to work for UL. And one of the first questions, you know, on the job was, do you know what a standard is? And I'm thinking, well, like, you know, meter, kilogram, that kind of thing. Well, so I was in for an education. So I spent the first 20 years of my career at UL really first evaluating manufacturers' products to UL standards for conformity. I was in the fire protection area, so surface burning characteristics, the flammability, rate of flame propagation was probably my first year and a half before I started getting involved in other things. So that was 20 years. That took me to about 2003 when I actually moved over into the standards organization, and I spent about 12 years serving as a full-time consensus body chair covering a host of UL standards. I had our entire fire portfolio at one point in time, lighting, security, I ended up getting involved in sustainability for the final few years of that, as far as environmental impacts, how to identify environmentally leading products. And so we have a variety of standards that cover that. Then I spent 2.5 years doing international relations, traveling the globe, making partnerships with national and regional standards bodies, sharing our standards portfolio, whether they ended up adopting a UL standard or they would simply have access to all the information in it, if that helped them create better standards in their own country, if it saved one life or stopped one fire. To us, that was mission fulfillment. So we basically gave them access to our entire library at no charge as part of our public safety mission. And then for the last 1.5 years, I've been leading the team that manages our entire standards portfolio as far as stakeholder engagement, application of our procedures, our accreditations. So humbly, kind of like Farmers Insurance, I can say, when it comes to standards, I know a thing or two because I've seen a thing or two, so I can say that. So what I'd like to do, let's see. So I want to cover a few things in the course of my presentation. I want to go over some thoughts on standards development, just at a high level, trying to supplement what you've already heard today and not repeat things. Information technology standards, then and now, where we started, what's happening right now. Talk a little bit more in detail regarding battery safety, which is really bright on our radar scope, no pun intended. And then close with just some comments about mitigating risks and realizing opportunities. So some thoughts on standards development, the world as we know it. And everybody's kind of talking about standards are everywhere. You turn on a light, the light comes on. You open the faucet, the water flows. Very, very true stuff. In 2014, we had a new chief operating officer come into our not-for-profit organization. Tom's smiling because you know who I'm talking about. And this gentleman was brand new to our line of work, and he had a marketing background. Did I mention earlier that I have an engineering background? So you probably see this is not going to end well. He made his first trip down to our offices in North Carolina, and we went out for dinner. It was my boss, who was the vice president of standards at the time, and several of the leadership team, and this new COO. And I didn't know it at first, but he was the kind of guy who loved to hit you with a question just out of the blue, kind of, catch you off balance, try and get you thinking. That was his style. And so he asked me, just turned to me, cold blank, said, "So, why are standards important?" And I had not really thought of the answer to that question, but I answered him. I said, because they enable civilization. Actually, that's not exactly, well, that is exactly what I said. That's not how I said it. It was more like, because they enable civilization. There was kind of a duh to my answer, which probably didn't help our relationship all that much. But I survived him. I'm onto a new guy now who's actually got a legal background. And to me, engineers and lawyers, we can talk, right? Detailed minds, organized minds, things are much better now. So the world as we know it, standards are just pervasive in everything that you can imagine. None of us is as smart as all of us. This goes to some of the conversations earlier about having a balanced committee, and it's not just having the engineers there and the people with the technical knowledge. It's about having a consensus body where you really have the variety of expertise around that product's use in the marketplace. That having a consumer at the table for a consumer product is critical. They're not going to understand all the science behind some of the technical requirements, but they're going to have pretty strong opinions about how that product is used and when you don't need to have a safety feature, but you can just get by with a marking instead, right? They're critical. Electrical inspectors come to the table with knowledge that the manufacturers don't have. They see how these things are actually being installed in the field, and that's knowledge that other people at the table don't have. One great example from my career years ago, I was chairing our consensus body that maintained all of the standards for personal flotation devices, life jackets. And we had, it was before it was a consensus process. Essentially, we published what the Coast Guard decided they wanted the requirements to be, because they had the responsibility for approving life jackets. The federal government, like the FDA approves drugs, the Coast Guard approves life jackets, and so they had a senior engineer on staff who really wore that responsibility like an enormous burden. He very, very dedicated, very focused on always doing the right thing. And I remember we got into a protracted discussion regarding grab straps on the back of a life jacket, which was kind of designed that you could, grab somebody and pull them perhaps to the side of a boat. All right. His concern was he didn't want, like in a rescue operation, some helicopter guy to come down and hook something to that if it couldn't support the weight of the person's body. And so we had this debate going on and on, and I think we maybe over 2 or 3 meetings it kept coming up, and we couldn't resolve it. The industry thought it was a silly requirement, and another marking adds cost or just alters the look of the product. They didn't want to do it. And so we had a young captain from the Coast Guard who had rotated from actual search and rescue, who was then in the Office of Boating Safety, and he was at one of our meetings. And he, again, having the right person with the right knowledge to resolve a requirement, he said, you could put a label on that thing telling me to use it, and I'm not going to use it. In other words, totally dispelled that this was a requirement that had to happen. And like that, we were past it. So, really having somebody at the table who's got the knowledge, having that, round, balanced group, of expertise is so critical. Consensus standards, essential ingredients. Earlier we talked about how fast can a standard be developed, and certainly if there's urgency, if there's a public safety crisis, and we'll talk a little bit later about hoverboards as an example, you can get people come together and they'll find a solution far more quickly. People are faster to compromise, they're looking to get that document out. If there's government pressure, especially folks tend to like, or industry tends to like, voluntary consensus standards, such as those produced by ASTM and ITripleE and UL and NFPA, because they're easier to maintain. They can respond faster to changes in design, changes in the marketplace. If the federal government passes a law through Congress regarding what the requirements are, your ability to get those updated is extremely, extremely difficult. So, having voluntary consensus standards is always a better solution. If you don't have that urgency, I've always said one of the essential ingredients is stakeholder fatigue. You'll be able to publish a standard after 3 years that you could never have published in 6 months. Two documents could be identical, but at 6 months, people weren't convinced yet that they weren't going to get their way. Right? They were still holding out that, I know what I'm doing and everybody else doesn't know what they're doing, to Dorothy's point earlier. So stakeholder fatigue, I think, is also a real, critical part of what's an essential ingredient of standards development. I talked earlier about, fast or slow, depending on whether you're opposed to it or you're supportive of it. And I always told my consensus bodies that, my objective was to achieve consensus. We had to have a supermajority supporting the document. We had to, respond to all comments. At the end, we had to achieve consensus. And so, to me, I said, if we publish a standard that absolutely everybody at this table is equally angry about, that's success in my book, So if everybody's equally unhappy, you've probably struck about the best compromise that you can. Human relations. Again, and everybody who's been involved with standards development knows this. We're under pressure sometimes. Can we do more with virtual meetings and whatnot? And we do try and do that when it's appropriate. But I so much, instruct my direct reports, when there's controversy, get people together. We are human beings, and the worst form of communication is email, right? Picking up the phone is the second worst form of communication, right? Face to face, we communicate in so many ways that are nonverbal or even spoken. And a classic example of this one was years ago. I was chairing a consensus body on underground flammable liquid storage tanks, and we had the steel tank manufacturers and we had the fiberglass tank manufacturers, and they couldn't agree on anything. We had some really contentious issues that we've been fighting about forever. And we had to schedule a meeting, and I couldn't get a conference room at a UL office, which we typically tried to do just for expense reasons. So we had to go off-site, and we met in a Hyatt ballroom just down the road from our headquarters in Northbrook. And the day 2 of the meeting, all of a sudden we got a lot of stuff done. And what had happened was that all these people, if we'd had a meeting at a UL office, they all would have stayed at different hotels in the area, right? But because we were having the meeting at that Hyatt, they all stayed at the Hyatt. Well, guess what they did? They went out for dinner together, and then they had maybe a beer or two in the bar, and they figured out the other guys were human beings as well. They talked through some issues, and they actually came to the table the next day with some compromises. So again, some thoughts on standards development. So information technology standards then and now. So we certified the first personal computer back in 1978, and we had a standard for that. And those standards have evolved so extensively since 1978, really in response to how technology has changed, right? Guess what? Copy machines are now fax machines too, and they're actually scanners as well. And our computers actually play music, and so they show movies. So used to have separate standards for information technology and audio-visual equipment. So there's been a lot of documents eliminated, documents consolidated to really track the technology changes. We talked about how extensively, really, information technology standards have become globalized in response to it being a global marketplace for laptops, for cell phones, right? Somebody builds a product, they do want to sell it around the world, and they're doing that. And harmonizing requirements, having a single standard that covers the globe takes a lot of work, and it takes a lot of time to maintain those standards. And so it's the industry support for harmonization that typically, in my experience, drives those that standardization internationally. So talking about information technology today, where do you start? Right? Think about what we mean when we talk about information technology, which, according to Wikipedia, all right, is the use of computers to store, retrieve, transmit, and manipulate data or information. So, information technology, right? I had to replace my cordless toothbrush last fall, and I went on to Amazon searching for a new one, and all the models that came up in the first search were like Bluetooth connected. It's like, why would I want a cordless toothbrush that was Bluetooth connected, right? So it can talk to my iPhone and store data. Maybe there's some app for like toothbrushing analysis. No, I didn't want it. Had to search to find a toothbrush that did not have those features. So I'm not going to try and cover all of the standards that we have now that probably would fall under the umbrella of information technology. Instead, what I want to do in my short time remaining is sort of talk about some of the major frontiers that we're looking at right now with respect to information technology products. So cybersecurity is a big one, and we do have a number of standards that we've published under the 2900 series of software cybersecurity for network connectable products. We have -1 is a general requirement standard. We have a 2-1 on healthcare products. We have a 2-3 under development on security systems and life safety signaling systems, so unique standards for those particular industries. Earlier it was talked about cybersecurity. Like Gordon, my early career was all about fire, shock, and casualty hazards, right? And these things we know about. They're science-based, right? Security, and before even cybersecurity, I was involved in things like bank vaults and ATMs and night depositories and key locks and combination locks, things that we evaluated for criminal attack, right? And that was a whole new world to me because, the nice thing about fire is fire doesn't like recalculate and change tactics, when you come up with a good sprinkler, right, Tom? Or put out different kinds of smoke once you've settled on a smoke detector, standard. It's chemistry and it's physics and the same with electrical safety and really casualty hazards as well. But when you get that criminal element behind what you're trying to protect against, it's a constantly moving target. That doesn't mean you can't have standards that help mitigate those risks. Our cybersecurity standards are really more design standards, things that you have to go through in the design process to try and check the boxes and avoid pitfalls and provide a level of protection. And we very much, there's some debate with some individuals within our organization, but from our perspective, we're cognizant that our stakeholders, the public's perspective on what constitutes safety is changing, and it can't just be fire, shock, and casualty hazards anymore, right? If you buy a refrigerator that's got a UL mark on it or some other organization's certification mark on it, and somebody hacks it and is able to set your house on fire, all right, I don't think anybody in this room would consider that to be a safe refrigerator, not in the days of internet connectivity where everything's talking to each other. So this has to be part of our dialogue on product safety. Information privacy, connected to cybersecurity, but also different. There's new regulations that just came into effect, GDPR in Europe last year, about what you can do with information and what you have to keep private and your responsibilities and significant fines if you share information that you shouldn't have shared. Within the US and the healthcare community, there's the same thing with like HIPAA laws, right? So as products have more and more data about us, who can get that? Even not in a cybersecurity situation, but just a normal commerce, how that information flows is part of the equation. Is it safety? I think there's an expectation, that a safe product is also about, protecting my personal information. And so that's on the radar scope as well. Oh, and another compatibility problem, just like Gordon had. So UL 5500, this is a standard that we published. It's an American national standard on remote uploadable software. And so again, not exactly cybersecurity, but also connected. So anytime you're used to updating your apps, right? Download the latest patch. This standard is about what has to happen between confirming the host, confirming the product, confirming the compatibility of the download, having a robust connection that if it gets interrupted, it doesn't leave your product either in a state where it's hazardous or vulnerable to attack. The main issue here is about the safety of the end product, still complying with the end product safety requirements. It's not about other aspects of performance. But right now, we're in the process now that we have this standard of engaging all of our other consensus bodies to say, do these products, are they capable of remote software upload? And if so, how do we connect this standard on tin-clad fire doors to the standard on 5500 for this new safety evaluation? Interoperability, and this gets really complex really fast. Everything's talking to everything else, right? What can go wrong, right? What are the failure modes that we haven't thought about before? We're involved in, I had the joy of being the co-chair of our standard development effort with the Association for the Advancement of Medical Instrumentation, AMI, around medical device interoperability. And this is something that the joy of it was that it's about better patient outcomes, right? The opportunities that we have, and we talk about risks so much, hacking, what can go wrong, but the beauty of this is what can go right if we start having medical devices communicating with each other and being able to raise flags for the clinical staff to say, there's a combination of things happening here that you need to pay attention to. A lot of sensitivity within this group that interoperability can't mean practicing medicine. So it can't be, hey, we measured this blood pressure and we got this oxygen level, let's give them another dose of drugs. No, it's more about providing information to the clinical staff. Autonomous vehicles. We are in the early stages. We have a task group well engaged to develop a UL standard on the safety for the evaluation of autonomous vehicles, so basically self-driving cars. And we're engaged with the federal government as well as advocates for this technology in the marketplace. Again, when it's autonomous and your concern is public safety, how do you have a standard that delivers on that safety obligation? Artificial intelligence, it's coming to everything. And I worry about this one, especially with my toothbrush. What will happen when it becomes self-aware, right? Earlier we talked, Gordon Gillerman, NIST, had a workshop in Gaithersburg on artificial intelligence here about a month ago, and brought together just leading minds around what's coming at us. And this one, to me, I have a really difficult time wrapping my brain around, how you deal with product safety when the product is going to learn on its own. How do you embed the requirement of human safety, of property protection into some sort of initial software when that software is going to learn and perhaps go beyond you, to the point where you may not be able to understand why it's doing what it's doing any longer. The future is going to be interesting. Batteries, and I've only got a couple minutes left, so I'm going to move through this stuff pretty quick. We are heavily involved in battery safety. We have a slew of standards that cover different technologies, different battery uses. This is a constantly evolving area, and you're all familiar with the hazards associated with batteries. You've heard of people who have been killed by exploding batteries in e-cigarettes. You've read about people who have been burned on airliners when their headphones caught on fire. It's a significant challenge, and it's a moving target because everybody wants longer battery life. That means more power. Everybody wants lighter products. That means less weight, so you're using fewer materials. Everybody wants faster charging times, also design changes. A moving target. So a case in point real quickly, 2015, December, right before Christmas, there was a hot new product called hoverboards. And this is just a few of the articles that appeared over that time frame regarding hoverboard fires these things were catching on fire. UL did not have a standard for hoverboards. We had not certified any hoverboards. I think there were some hoverboard manufacturers that may have misused our mark because they went out and they found a UL listed power supply that they were going to use to charge a hoverboard, and so they were pulling our label into it. We put a stop to that. But what happened in December 2015 was the Consumer Product Safety Commission came to UL and said, we need your help on this. And so we put a team of engineers on this, applying hazard-based safety engineering requirements, and they came up with initial requirements, I think it was by the end of February of 2016. Not a consensus standard, so not a UL standard, but requirements that CPSC ended up invoking and saying, you're going to sell a hoverboard in the United States, it's going to comply with this UL outline of investigation, which is kind of an initial document for us before we have a consensus standard. That was the end of February. I think by November we had a consensus standard, and since that time our standard has been picked up internationally. I think with just within the last month it was adopted in Singapore, for example, to mitigate the hazards associated with these products. So, just to give you a quick idea, a little bit of case in point. This is just a short video of a induced thermal runaway event in a hoverboard. It gets more exciting. Look at the distance of the projectile flaming. And think about this thing going off in your garage or living room while you're charging it. I think that's it. So just final closing comments. Mitigating risk, but also realizing opportunities. And I spoke to this a little bit. So certainly the technologies keep changing. right? And we need to figure out what can go wrong, how do we stop it from going wrong. Things start talking to each other, what does that mean? What are the combinations that are now possible that weren't possible before? But also, as one of my colleagues testified to CPSC last summer, we have to look for the opportunities too. Right? So if our smoke detectors can start talking to our stoves, and the stove can say, hey, Dan's making garlic bread again, calm down. There are things that can happen now that couldn't happen before. And so, we can end up with a safer world if we can leverage the opportunities while still, working to mitigate the risks. So thanks.
Okay, so at this time, we have a little bit of time for questions for both of our speakers. So do you have any questions?
Maybe too detailed of a question, but I saw 802.3 CRs that said isolation. Could you tell me what that's all about?
An 802.3 standard? Yeah. I can find an answer for you. Yeah.
Any other questions? Okay, I do have one. So I noticed in your presentation you talked about the fact that there is actually a public review of the documents before they go on to be voted on. So how do you handle negative comments or commentary that maybe isn't as technical in nature, but there are again comments being made on the standards? Do you have to read through each one? How do you address all of these comments if public can have some say on the document?
Okay. Comments that come in during the public review process are handled just like any other comment that would come through in any other stage of review. There are a set of requirements. The comment has to be responded to, so it must be considered. And if it's a technical comment or an editorial comment, a rationale describing the reason a change was made because of the comment or why the comment is rejected, a technical reason must be provided. So if it's an editorial comment, for example, that says, expand acronyms in a different place, well, that's one thing. Either you do it or you don't do it. But every technical comment must be addressed and considered by the committee and a response generated to indicate the disposition and the rationale.
Okay, thank you. Any other questions? Perhaps each of you and anybody else left could give some feedback to students. What would be important for students at this stage if they're an undergraduate or graduate student needing to learn about standards or perhaps getting involved? Maybe some thoughts for them.
I think that I was thinking about this a little earlier today. I think that somebody was talking, I think Gordon was talking about how China has curricula where people are actually getting degrees in like standards development and they're being incentivized to participate. I think that having the right answers, you're not going to be successful, right? Being the smartest person at the table, you're not going to be successful. You need to be the most persuasive person at the table. So I think communication skills are so critical. It's about knowing the science and knowing what you think the requirements ought to be, but it's also about being able to present what you know in a way that other people at the table will be able to understand it and that you're going to be able to influence them. So being right and being smart won't cut it, but being able to communicate and form those human relations is, I think, essential to being successful in standards development.
I would add listening skills, because it's one thing, and it's important, it's critical to convey your perspective, describe your data, describe the methodology used, the rationale, all of that. That's absolutely essential. That's a baseline. I think what differentiates the really successful standards participants is the ability to listen and comprehend, make an effort to really comprehend the points being made by the other party. So often people talk past each other, or they're coming from different understandings, or they think they disagree, but really they're saying the same thing. But to recognize that helps to move the conversation along quicker. And so I would say listening skills and just, I think a lot of the work now in universities, it's very team-based, right? You have a lot of team projects. Individual people are not silos. And so the skills that you learn there, I think, will be leveraged in any standards participation work that you do.
Very well said.
Thanks for asking that question. One thing and I mean this with great sincerity, I've hired and fired a lot of people over my career, and on interviewing, if a candidate is completely unaware of standards, they're never going to get a job with me. And I think that's common, and that's one of the motivations that Ya-Ting and I really talked about is our goal, and I think everybody's, the experts that have spoken today have shared their heart and experience. And I know this may seem very mundane, but literally it's the difference between success and failure when you leave here. If you choose to do something as far as whether it's academia or in industry, if you don't know standards, you're probably not going to go far. But on the other hand, if someone has, and I don't mean you have to have a PhD in standards, but if you have a working knowledge of what a standard is, how it's used, and everything else, it's an exceptionally valuable part of your career. And I feel really strongly. So it's a really great question.
And just to add to that, I'm one of those examples. So I got involved in a standards organization during my PhD time. And by getting involved and learning about how the standards were developed, I learned how they were also beneficial for some of my research. And by going to the meetings and interacting with people on the committees, I grew my network. So it was a great networking opportunity as well. My dissertation was that much better because I had those particular experiences. And now that I'm past the PhD and I'm in academia, I now know people when I have a question and I'm not quite sure how to tackle it, I can go to somebody at one of these organizations and they can help lead me down a path that's going to be beneficial. So from a personal experience, it's great to get involved, learn about the standards early on, because you never know what kinds of doors those can open for you downstream. Well, let's give our speakers another round of applause for Dorothy and Daniel.